Hi friends, welcome to my channel VLSI Gyan. Friends, in this session, we will discuss about the very basic thing that is FPGA and ASIC. Many times we hear about these integrated circuits, but we'll see today what is FPGA, what is ASIC, and what is the difference between these two and when to use FPGA and ASIC. So before going into the video, I just request you if you're watching for the first time, please subscribe to my channel to get all the stuff related to VLSI. So friends, let us see what is FPGA. As we all know, FPGA is Field Programmable Gate Array is a kind of semiconductor device that contains an array of programmable logic blocks. These are called configurable logic blocks, CLBs, and we have interconnects and switching matrix. So we are not going into the detail about the structure of FPGA. Just remember that FPGA is reconfigurable, that whatever the logic you want to design, that you can implement in the FPGA. So it allows the user to implement the digital circuits by programming them rather than by manufacturing custom chips. So FPGA is like a board on which you program your digital circuit. Okay, so when you are getting the FPGA, it is like a plain board and on which you are going to implement your design. So what are the advantages of FPGAs? So mainly FPGAs are flexible and they are reconfigured. FPGA can be reprogrammed multiple times to perform different tasks or adapt to changing requirements. So when your requirements change, so there is no need for the designing new, manufacturing new chips. Instead of that, you can implement the change in your FPGA, right? So they are used for rapid prototyping. If we want to design any big digital design, that time we can go for prototyping. So rapid prototyping is possible with FPGAs. Ideal for prototyping and development, allowing quick iterations and testing. We can go for multiple iterations and testing of designs without requiring physical manufacturing, right? Next advantage we can see is time to market. Okay, so time to market is like shorter development time due to the flexibility in design iterations and avoiding long fabrication cycles. Lower non-recurring engineering cost. Engineering cost, non-recurring engineering cost, NRE cost is nothing but the overall cost of a product which is the cost incurred in design and development of that product. So reduced upfront cost compared to ASICs, as there is no need for costly mask fabrications, right? Then upgradability. FPGAs can be updated or upgraded in the field, so enabling design modifications after development. As already discussed, we can change it, we can make the changes into the FPGA design, we can make the changes in our design in the FPGA in the field. So it is not like your chip is wasted. If there is any modification, you can make the changes in your FPGA design. So these are the advantages of FPGAs. Let us highlight some disadvantages also. So what are the disadvantages? Lower performance and high power consumption. FPGAs have lower performance compared to ASICs and consume more power due to general purpose architecture. Okay, so as they are not specific for any design, they are like a plain white paper on which whatever you want to write, you can write. So similarly, FPGAs are the boards or the ICs on which whatever the design you want to implement, you can implement. So they are general, so their performance is not that good as compared to ASICs. And they consume a higher power consumption also because of the general purpose architecture. Then higher unit cost. Individual FPGAs can be more expensive compared to ASICs for high volume production. Okay. Then limited resources. Logic resources, memories, and processing capabilities compared to custom ASICs. So these are as general purpose. So they have the limited resources when you compare with the custom ASICs. So let us go and see what are the advantages and disadvantages of ASICs. ASIC, also called as application specific integrated circuit. Okay. So ASIC refers to an integrated circuit specially designed for a particular application or task. ASICs are custom designed and optimized for a specific function or a set of functions. These are the integrated circuits which are manufactured only for performing a specific function or a task. Okay, for a particular application only they are designed. So when they are designed, before that only whatever the logic is there, that is implemented on these chips, and it is only for that design it is manufactured. Okay, so what are the advantages of ASICs? High performance. ASICs are optimized for specific tasks, leading to high performance. They consume very less power, so low power consumption. Okay, and faster operation as compared to FPGAs, because they are custom designed. They are designed only for a particular application, so they have a better performance. Anyhow, they will exhibit a better performance, that is all known. And also they are consume less power, because the circuitry whatever is there in the design, that is only the part, so less power consumption and faster operation compared to FPGAs. Okay, then lower unit cost for volume production. If you are going for longer, large number of ASICs, then when you go consider the unit cost, that time the unit cost for ASIC is less. Okay, once the design is finalized, ASICs can be more cost effective in large production volumes compared to FPGAs. Customization. ASICs allow full customization, enabling designers to optimize the chip for a specific application, resulting in better performance and efficiency. Now let us highlight the disadvantages also. So first is high NRE cost. NRE is non-recurring engineering cost. ASIC development incurs high non-recurring engineering cost due to the mask fabrication, testing, and design iterations. Okay, to get the optimized design, the perfect design, we need to go for many times the design iterations are done. Many times the design is changed, verification, and all this like fabrication, testing, and all this results to high non-recurring engineering cost. And because of this, it requires a lot of time. So ASIC development takes lot of time, longer cycles due to the complex design, fabrication, and verification process. And because of that, it takes a large time or a huge time to come to the market, right? And less flexibility. ASICs lack reconfigurability. As we know, they cannot be reconfigured at the field. So you cannot, once the chip is manufactured, we cannot make any changes into that design. Any design changes require a new chip fabrication, and making them very less adaptable to the changing requirements. So these are the disadvantages. So when to use FPGA and when to use a ASIC. So the decision between FPGA and ASIC depends on the factors such as design complexity, performance requirements, time to market, production volume, cost, and reconfigurability needs. FPGA for prototyping and rapid development. FPGAs are suitable for rapid prototyping, development, low to medium volume production, and applications that require flexibility and field upgradability. So when you are going for a prototyping, you can choose FPGA. When you have a low to medium volume production, then you can choose FPGA. If you have high volume production, if you are choosing FPGA, the cost will be more. So like that, we have to make the choice. Then if you require flexibility, means you assume that there may be some changes later. So that time it is better to go with FPGA, because once you are going for ASIC, for if there are any changes, you have to go for a new chip design, right? So that is not possible with FPGA. So if your design needs a rapid prototyping, you can choose FPGA. If you have low to medium volume production, you can choose FPGA. If you require flexibility and upgradability, then also you can go for FPGA. And when to use ASIC? ASIC for high volume and performance critical applications. The designs which require high performance, demanding high performance, and situations where unit cost, power efficiency, and customization are crucial, that time you can choose a ASIC. Okay, and when you are producing a high volume production, when you are producing more and more number of the chips, then it is better to choose a ASIC, because when you are going for higher volume, then the cost will be less, per unit cost will be less as compared to FPGAs. And also when you require high performance, then also you can go for FPGA, because they are application specific, they exhibit high performance as compared to FPGAs. And also power efficiency and all, when these are the important factors in your design, then you can go for ASICs. So it is up to the designer to choose which is better, either FPGA or the ASICs. So friends, I hope this video has given you a basic idea about FPGA and ASIC, and what are the advantages and disadvantages of FPGA and ASIC, and also when to use FPGA and when to choose ASIC. So that's it for this video. Thanks for watching, and please like, share, and subscribe to my channel. Thank you.